Hi, and thanks for watching my video about my homebrew computer. Today I wanted to give a update on how I'm using the extended memory capabilities of the homebrew computer to enable me to run chiptunes in the background whilst other regular programs can continue to run in the foreground by using ROM and RAM banking. As you can see here on the homebrew, it claims to have 128K memory. As you will know, the 6502 can only have an addressable memory of 64K. So how does it do that? By ROM and RAM banking, of course. Quite a common technique back in the 80s to extend the memory capabilities of many home computers. And I've used a similar approach here. Why do I talk about ROM and RAM? Well, the 128K that you see on the screen, it claims, is for the RAM. There's also 64K of ROM. And in fact, let's do a little bit of theory of operation, shall we? Just to quickly give you an idea of what what I'm getting at here in terms of how I've designed this. So my homebrew has two input output chips, two 6522 versatile interface adapters, VIAs, and one of them, the VIA1, in fact, it has control over whether ROM is enabled or not. So there's a if you trace this line, it goes to the address decoder, and port B, bit 5, is used to decide whether uh, the ROM space or the top of memory, the top 16K of memory, should be addressed as ROM or RAM. So that allows me to swap in RAM if I want to. And then VAI1, it has a 4 bits which are of port B, which go to the address decoder. That allows the address decoder to select one of 4 banks of ROM or 4 banks of RAM, and that's how I basically can load quite a lot of code. So the 64K of ROM of the homebrew, I need it because I've got the interpreter in one bank, I've got some graphics utilities in another bank, I've got the file system and SD card handling in another bank. So I couldn't fit all that into 16K, so I've got 4 banks of 16K. But I never really made use of the RAM. So let me just go to the next page of this theory of operation and just explain how this looks in practice. The 6502 only sees locations 0 to FF. That's the 16-bit address bus, um, and when it boots up from power on, by default, as you'd expect, ROM is enabled. So the top 16K, only one of the banks of ROM is visible. The RAM underneath is not visible, but location 8000 to the top of memory does select one of the 4 RAM banks. You'd only select RAM bank 1 to 3 because RAM bank 0 is the bottom 32K of memory. But when ROM is enabled, you can't really access the top part of the RAM bank. So that's where. But when you disable the ROM, then of course you have the top of 32K of the address map, of the addressing, can access all of the RAM, and you can select one of the 3 banks available to you. By default, on power up, um, the homebrew starts in bank 3. Uh, and so that's all there is to really say about the address map. Um, as an aside, there's also 16K of video RAM because the TMS 9918A has its own memory, and so actually this homebrew contains 64K of ROM, 128K of RAM, and 16K of VRAM. So it's over 200K, 208K. If I've added it up correctly. So that's basically the memory map. Now let's go and see how this actually works out on the computer. Don't worry about the battery issue and checksum. I think there's something wrong with my battery backup here. which has decided to suddenly go wrong for my Alice clock, real-time clock chip. Anyway, it doesn't affect this demo. So by default, if I do print, let's look at the hex version of it, peak of location 400 hex. That is actually VAI 0 port B, and 00BF is what's in there, and the top nibble is the important one. So B is 1010. So 10 is the ROM bank, which is 2. That's the currently executing ROM bank, and then B, sorry, the other 2 bits is it's 1011. So the other 2 bits are 11, which is RAM bank 3. So as I said, that's where by default it fires up. If I was to do a dump of memory location 8000, which is where the RAM bank starts, you'll see it's all 0 because it's been initialized on power up. But my power up routines only initializes bank 3. I just leave the other banks for the user to do whatever they need. So let's change bank. So we're going to poke 400. Instead of with BF, let's poke it with AF. So that's 1010, which is bank 2. Now if I do a dump of that location, you can see there's something already in there, and I'll get to that in a minute, but I can poke 8 to 8000. Let's say put value 2, which represents it being in bank. We know we're in bank 2. And if I then, you can see there's, if I dump there, you can see there's location 8000, it's got the value 2. But if I now go back to my original bank, so I need to poke the port register B with BF, and then let's dump out memory 8000, and as you can see it's still 0 because that's how it was initialized on power up. So great, you may say, how can we access this practically? So I've written some routines that loads chiptune into the shadow RAM bank 2, and I've also then converted a Protracker mod player, which I found. So Protracker is a format that was popular for the ZX Spectrum and I think Amstrad, and that's a Z80 machine, of course. But someone did a 6502 port, so I've taken that port and I've adapted it for my Homebrew. Let's go into a directory where I've got some demos of this. So there's a whole bunch of Protracker chiptunes, and of course I didn't write any of this, so I just converted them or got hold of them and uploaded them onto the SD card, and I've adapted the Protracker player, as I said. Now the way then what I've done then is added some commands in D flat. So if I do pt load, we'll be able to load into a location. Which location in bank 2? I'll use 8000 again, and let's load this. You'll probably guess what it is just from the file name, and then I can do something called pt init, which initializes the Protracker player, and that parameter says you should loop. So hopefully an instantly familiar tune to Nintendo, for Nintendo fans. I can let's just pause that for a minute. So as you can see, I'm able to type, and in fact I won't pause that. I'll just go to another part of so then we go, let's go to demos, and there I go to space. So as you can see, I'm able to just type and carry on using the computer while the tune is going on in the background. And the way that's working is that VAI1 has a 50 Hertz interrupt, so 20 millisecond interrupt, which is attached to the non-maskable interrupt line of the 6502. Let's just pause that for a minute. So the VAI1, which is just here underneath, and it's not very good, is it? It's just underneath this ribbon cable. That is attached to the non-maskable interrupt of the 6502, which is here, and the 50 Hertz interrupt then invokes the interrupt handler, which basically runs one tick of the Protracker player. But if I load show.prg, what we can see is, and then I can turn the tune back on. In fact, let's load another tune. So pt load. No, I can't load another tune because I'm in the wrong directory now. But let's start this one off again. Pt run. So start with 1. It will continue from where it is. And as you can see, I can just do whatever I want. I can list my current program. It doesn't interfere with anything else. And I can, in fact, just run things. And this is my favourite set of pictures from back in the day. So that's it really. That's the example of how this is running in the background. And just out of for the curious, these 4 lines here, you might not be able to see very well, but there's a red, orange, yellow and green set of wires. They come from VAI0, which, as I said to you, it controls which bank of ROM and RAM, and that goes off to the address decoding circuitry here to then select the appropriate address lines of RAM or ROM depending on what's being asked for. So let's just kill that for a minute. And as you can see, the clock, I've just rebooted and now the clock is happy again, so I don't know what's happened there, but let's go back to the folder, because I would like to do one other little tune, because there's so many, and I've actually found tons and tons of tunes, and I've just taken a selection for putting on the SD card, but I would like to play this one as a final sign off. Again, you're going to have an idea of what this is. Let's run it.